We are finding the equation to the tangent line, and it's going to be at the point pi over 4 is our x and our y is 1. So here's our function that's been defined, f of x equal to tan squared of x. And so the first thing we're going to want to do is find the derivative. We're going to find the derivative first. So what we're going to do here is you take the 2, you bring it out front, you rewrite everything, and then we take the derivative of the inside and chain it out. And the derivative of tan x is secant squared x. It would probably be best if I had parentheses completely around this and then raised to the second power. You might see that a little better, but I don't. So hopefully you know how it went from here to here. And you're supposed to already know what the derivative of tan x is, which is secant squared x. If you don't, I think I worked that out somewhere in some earlier problems. Um, okay, so what I did is, what did I do? I don't know why I did this. I think I wanted to get everything into sines and cosines. Yeah, that's what it looks like. Okay. Um, let me just say something here real quick. I probably worked this problem out 2 months ago and typed it up. And so I'm just now getting around to making the video of it. So that's the reason, I'm kind of looking at this and going, oh, how did I get to here and this and that. So you might have wondered in some previous videos that these problems were worked out months ago and maybe some of them years ago. I don't know. Anyway, but I did go through and second check and make sure everything's correct. But okay, so let's move on. So I got everything into sines and cosines, and then I went ahead and plugged pi force in because I think it's just going to be a whole lot easier to remember, hey, what's the sine of pi force instead of what's the tan of pi force? Anyway, and so that's what I do. And then we got the cosine of pi force here. And then I plugged pi force in over here at cosine squared. So you need to know what the sine of pi force is equal to, and it's equal to the square root of 2 over 2, and the cosine of pi force is also equal to the square root of 2 over 2, and of course that's going to all cancel out to be 1, and then we have the 2 carried over here. And then we've got to, let's see, the square root of 2 over 2 squared, so we're going to square the square root of 2, which just gives us a 2, and then you square 2 and you get 4, and then we're going to do a little flipping around here, but the whole thing equals to 4. So it looks like that the slope of the tangent line at pi force is 4. Okay, so the goal is to find y is equal to mx plus b. Well, we found m, and m, which is the slope, is 4. Now we want to solve for b in this equation. So we have our x, which is pi force, and our y, which was 1. This was the point. And now we want to solve for b in this problem, and so that's just going to all cancel out to pi, and bring it over, and we're going to end up getting 1 minus pi, and so b is equal to 1 minus pi, and therefore the equation to this tangent line is y is equal to 4x plus 1 minus pi. Now I think I've got a graph drawn somewhere. Let's take a look at it. Okay, so here it is. So here's our function. Okay, and this is our tangent line right here. Now I don't know, I've mentioned this so many times in the past, but you need to kind of keep this in mind, that this is not to scale. Okay, this is not to scale. I mean, look, we go over 1 unit in this direction, and going up 1 unit, it looks like 10 units here. But it's real easy to actually find the actual slope of this line in this picture. But it's not the true slope, because remember the true slope was 4, I believe. I meant 4, yeah. And this is definitely not 4. I mean, 4 would be, a whole lot steeper. But you can see here that the y-axis has been squeezed